Welcome back. In this video, we're going to try to find the exponential form of u, which is given by 1 over 1 plus I tangent of alpha. Here, to have the tangent defined, we can let alpha be different from pi over 2 plus n pi with n in z. Okay, so this is because the tangent is periodic of period pi. We don't want alpha to be one of these numbers. Okay, so this is the first thing that we're gonna do. Next is we can write u in some simplified form by using the expression of the tangent. So we know that the tangent of alpha is just sine of alpha over cosine of alpha. Okay, so using that, we're gonna have u is 1 over 1 plus I sine alpha over cosine alpha. We can simplify one more time to get cosine alpha over cosine alpha plus I sine alpha. So according to Euler's formula, we know this one here. So we know that cosine alpha over, this is EI alpha. Okay, and if we multiply by the conjugate, we're gonna get cosine alpha e to minus I alpha. Okay, so multiplying by the conjugate, which is e to minus I alpha, and here we're gonna have e I alpha times e to minus I alpha, which is e to 0, which is 1. So therefore, this is just for those who don't see the result here. Okay, so now I have u as cosine alpha e to minus I alpha. So to write it in a exponential form, I need to have u in this form. U is going to be the norm of u e to some I theta. Okay, that angle that I have to determine. But the norm of u, I need to find that as well. So here u has to be strictly positive. Okay, so this is one key of when we write the exponential form. We need to have this one positive all the time. Okay, here using the definition that the norm of u is just the square root of u times u bar. And this gives us that u is cosine alpha e to minus I alpha times cosine alpha. It's a real number, it's conjugated itself, and the conjugate of e to minus I alpha is I alpha. Therefore, I have the cosine squared of alpha, and this is just 1. The multiplication of the two conjugate is just 1, and the norm is therefore cosine, the absolute value of the cosine of alpha, because I don't know where alpha is located, so I can determine the sign here. Therefore, I have u, the norm, okay, and I can simplify this one more time. Okay, I can do it this way. Okay, so here when alpha is in here between minus pi over 2, and now the cosine, this is my angle alpha, let's say some alpha here, the cosine is positive. Okay, and therefore u is gonna be the norm of u, which is cosine alpha e to minus I alpha. But here, if I'm in here, if alpha is between minus pi over 2 plus 2k pi, with k some number in z, and pi over 2 plus 2k pi with k in z, therefore u is just cosine alpha e to minus I alpha. So this is the exponential form. Okay, if alpha is in here, okay, that means alpha is between pi over 2 plus 2k pi and 3 pi over 2 plus 2k pi, because I'm going back to the same point. That's why I have these 2 pi. Okay, after some k, some movement around the circle. Okay, So here, let's write it nicely. Alpha is between pi over 2 plus 2k pi and 3 pi over 2 plus 2k pi. Okay, what happens to the cosine of alpha? It's negative, and therefore I have minus cosine alpha to keep it positive. Now, if I go back here to write this one in exponential form when I'm in this part, when alpha is in here. Okay, when alpha is in here, it comes to this one after 2 pi. So when I'm in here, I can write this one as u is gonna be minus cosine alpha minus 1 e to minus I alpha. Okay, here this is positive. If I'm here, this is positive, and therefore I have this minus 1. I need to get rid of it because according to the definition here, this one has to be positive. So here I'm gonna write ei pi e to minus I alpha minus cosine alpha. Therefore I have minus cosine alpha e to I pi minus alpha. So this is u. So this is the exponential form when I'm here. And this is the exponential form when I'm here. When I'm here, I mean this one that I come to after 2 pi or 2k pi. Okay, so we have basically two forms. This one when I'm in this part, and this one when I'm here. Okay, remember this one. This is the key here. We need to have this one positive. That's why we had to treat these two cases, because we want to have this one here. We don't want to keep it like this, with the absolute value. You can simplify it. Okay, you could if you want, but most of the time it's good to simplify things. Okay, if you see any errors or mistakes, please let me know. Please like, share, and subscribe for more. Thank you.